Yesterday we kind of wrapped up our order of operations of our main operations, our basic operations, by adding powers and roots. Today I want to kind of step back a little bit. I threw the decimals in there at the end yesterday, but I want to step back and do a little bit more with the decimals today. Make sure we have all those operations down. Now, just like with whole numbers, the heart of understanding decimals comes back to these place values again. You know, we said starting at the end of the number or at the decimal point and working our way backwards, we had ones, tens, hundreds, 1,000s, 10,000s, 100,000s, and we can keep on going. Well, I wanted to write them out numerically like this so that we could see pattern developing here. Anytime I move one place value to the right, the value of that place is divided by 10. 10,000 divided by 10 is 1,000. 1,000 divided by 10 is 100. 100 divided by 10 is 10, and on down the line. Well, if I keep moving past my decimal point, that pattern continues. 1 divided by 10 is 1/10. 1/10 divided by 10 is 1/100th. 1/100th divided by 10 is 1/1000th. And divided by 10 again, 1/10,000th. And it continues on down. One of the things I get asked a lot by students is, why isn't there a ones place after the decimal, or a oneths place, whatever? Well, it's exactly because of this pattern that we see here. You have to divide by 10. Also, you might notice 10 is 10 to the 1, 100 is 10 squared, 1,000 is 10 to the third, 10 to the fourth is 10,000, 10 to the fifth is 100,000. Well, 10 to the 0 is actually 1. This is 10 to the negative 1 and 10 to the negative 2. We haven't talked about negative powers yet in their meaning, but they're called reciprocals. They're fractions. And because there is no negative of 0, there can't be a ones place on after the decimal point. That's the negative power of 10 place values. So if I have 0.084, now you might be looking at these decimals, these place values here, thinking, boy, those look suspiciously like fractions. Because that's exactly what they are. Decimals are nothing more than a shortcut way of writing fractions that have a particular denominator. And in our decimal system, in our base 10 number system, it's denominators that are powers of 10. So 0.084 actually is a fraction. It means we have 84 there. The place value of its last digit tells us the denominator of that fraction, which is 1,000. In fact, it is that simple to convert a decimal into a fraction. Now, of course, we reduce this. Both 84 and 1,000 can be divided by 4. 84 divided by 4 is 21. 1,000 divided by 4 is 250. And that's that. Well, we might have something like 0.0375. If I want to turn that into a fraction, well, again, it's just 375. The denominator, remember, is the place value of that last digit. So this is tenths, hundredths, thousandths, 10,000ths. So my denominator on that equivalent fraction is 10,000ths. Another way to double check that, there's 1, 2, 3, 4 decimal places in the decimal. There has to be 1, 2, 3, 4 zeros in that denominator. And of course, that can be reduced. So let's look at our operations then with these decimals. Remember, when we add or subtract, number one is we must have the same name. What does that mean for decimals? That means we have to line up the decimal points. Then, of course, we combine counts. We always combine counts. No matter what operation we're doing, we're going to combine counts in some form. And then we also combine the names. Or not combine the names, we keep the same name, I should say. Combining the names is multiplication and division. So keep the same name when we add or subtract. So for decimals, what that means is we drop the decimal point down, straight down. Okay, so let's look at some examples here. Let's take something like 4.83 plus 17.914. So when we go to set this up so that we can add, we have to make sure we line up those decimal points. So I write the top number, and generally what I'll do is I'll write for the bottom number, I put the decimal point in first so that I can work in each direction. So 17,914. And we are adding. Now we should fill in zeros for our missing decimal places. I'll put a 0 in right there for that missing place. And then we'll go ahead and add. 0 plus 4 is just 4. Well, 3 plus 1 is also 4. 8 and 9 is 17. Well, just like any other addition, we're going to keep the 7, and we'll carry the 1. So you notice the decimal point does not affect the carrying at all. And then, since we hit the decimal point, before we go on, we bring that decimal point straight down, and then we can continue to add. 1 and 4 is 5, plus 7 is 12, so it's 2 carry the 1, and then a 2. I'm not going to beat the addition over the head here, so let's move on to subtraction. So let's take something like, excuse me, 43.26 minus 9.843. So when we set this up, excuse me, same thing, we line up that decimal point, making sure everything's perfectly lined, and then, oops, what happened here? I'm going to have to restart Word here. Give me just a second. The joys of modern technology. Okay, hopefully we're good to go here again. So anyway, I don't remember what the numbers were at last time, but let's just make up a different problem, whatever. 42.36 minus 9.714. Again, I'm sure that's not the same numbers we had before, but it's going to work out the same. So again, we fill in that 0, that missing place value, and we go to subtract. Just like with whole numbers, 0 minus 4 can't be done, so we're going to borrow from that next digit. So the 6 becomes a 5, 0 becomes a 10. 10 minus 4 is 6, 5 minus 1 is 4. 3 minus 7 can't be done, so we borrow from the 2, we make it a 1. This is now 13. Notice again the decimal point did not affect our borrowing at all. 13 minus 7 is 6. Once again, we bring the decimal point straight down. 1 minus 9 can't be done, so we borrow from the 4, it becomes a 3, and this is now an 11. 11 minus 9 is 2, and we have the 3. So subtraction, again, is just like our whole numbers. The decimal does not affect the calculation. It just affects how we line up the digits, telling us where we have to fill in zeros, and then the decimal point comes straight down. For the rest of it, we pretty much ignore that decimal point as we do our calculation. Now, one I wanted to show you is one that looks like this. 34 minus 7.8356. So we have a whole number minus a decimal. We need to have a decimal in that whole number. And when there isn't one, it's at the end of the number. We just don't write it if there's no places after the decimal. So when we go to line this up, I have to put that decimal in at the end of the 34, so I have something to line up with. Then I have the 7.8356. And of course, I do have to put in those zeros. There's going to be 4 place values that I fill with zeros here. Now, when I go to subtract, 0 minus 6 can't be done, so I need to borrow. But there's nothing to borrow from here. That's a 0. So what I have to do is I have to keep going until I find something to borrow from, which is all the way over here at the 4. So I borrow from that 4, and it becomes a 3. But when we borrow, we're only borrowing one place value over. So what we borrowed there makes this a 10. Well, we need to get all the way down here, so we have to keep going. So we're just going to repeatedly borrow until we get to where we need to be. So now we'll borrow from this 10, make that a 9, and this is a 10. We'll borrow again, borrow from that 10, make it a 9, and this is a 10. And we'll borrow from that 10 to make it a 9, and finally this is a 10. Now it's where we need it to be. Now many of you are probably taught a shortcut to just borrow and then go 9, 9, 9, 10, which is what it comes out being, but it is actually several individual borrowings that are occurring there. So now we can go ahead and subtract. 10 minus 6, of course, is 4. 9 minus 5 is also 4. 9 minus 3 is 6. 9 minus 8 is 1. Once again, once we hit the decimal point, we have to bring that decimal point straight down before we pass it. 3 minus 7 can't be done, so borrow, that's a 2, and this is a 13. 13 minus 7 is 6, and we bring the 2 straight down. Again, I'm not going to bore you with a lot of examples of operations with the decimals there. Let's talk about multiplication and division. If you recall, when we multiply or divide, we do not need the same name. What that means for decimals is there is no need to line up decimal points. Of course, any operation we combine counts. When we multiply or divide, here is where we also combine the names. So this involves some sort of organized way of moving the decimal. or placing the decimal in the correct spot. So let's look at some examples here. Come on. Let's do 4.32 times 5.7. Notice when I set that up, I didn't bother trying to line up the decimal point. When I multiply now, similar to addition and subtraction, I'm going to totally ignore the decimal point. Different from addition and subtraction, though, I'm not even going to drop it down when I hit it. I am going to pretend it's not even there. So I'm going to do the 7 times 2, which is 14. So it's 4, carry the 1. 7 times 3 is 21, plus the 2 we carried is 22, so 2, carry the 2. And 7 times 4 is 28, plus 2 is 30, so that's 0, carry the 3. Now, before we move on to the next place value, in the bottom number, we were taught we have to put a 0 in down here. I also put a line up here just so that I know that anything below that line is old carries. I have different colors here so I can keep track, but on paper, of course, your pencil is generally only one color. Now we have 5 times 2, which is 10, so that's 0, carry the 1. 5 times 3 is 15, plus 1 is 16, that's 6, carry the 1. And 5 times 4 is 20, plus 1 is 21. So that's 1. There's no place to carry the 2, so we just move the 2 over to the next place value. We add these up. 4 plus 0 is 4. 2 plus 0 is 2. 0 plus 6 is 6. 3 plus 1 is 4, and we have the 2. Now, to place the decimal point, what we've been taught to do is count in our problem 1, 2, 3 total decimal places. Might be easier over here so it's not all crowded up. There's 3 decimal places in that problem. We have to have 3 decimal places in our answer. So starting at the end of the number, we count backwards, 1, 2, 3. That's where my decimal point has to go, 24.624. Now, there are a couple other ways we could have approached this. First of all, this is 2 hundredths, and this is 7 tenths. Hundredths times tenths is thousandths, so we have to have a thousandths place. Is that last digit. That result has to go in the thousandths place. Also, the other way we could have looked at it is, 4.32, well, that's about 4. 5.7, that's close to 6. 4 times 6 is 24. That's the only place that it makes sense to put that decimal point. 2.4624 would not make any sense with those numbers. That'd be way too small. And 246.24 would not make any sense. That'd be way too large. Now, one thing to be careful of when we're multiplying with decimals is a problem like this. So 0.735 times 4.72. So again, I'm going to start with the last digit of the bottom number. 2 times 5 is 10, so that's 0, carry the 1. 2 times 3 is 6, plus 1 is 7. 2 times 7 is 14, so that's 4. There's no digit to carry the 1 to, so we just move it over to the next space. So we're done with the last digit. We've combined it with every digit of the top number, so we move over to the next digit. We put a 0 in here. Now, technically, what we do down here is we put a 0 in for every digit that's to the right of the one we're going to use. That 2 is to the right of the 7, so there's 1 digit there. We put in 1 0. So now we combine. I'm going to put my line up here. 7 times 5 is 35. So this is 5, carry the 3. 7 times 3 is 21. Plus the 3 we carried is 24. So 4, carry the 2. And 7 times 7 is 49, plus the 2 is 51. So that's 1. Again, there's no place to carry the 5, so we just move it over. Now we're going to move over to the 4. There are 2 digits to the right of the 4, so I have to put in 2 zeros here. Again, that's because this was hundredths, this is ones, that's a multiple of 100. That's what those zeros are. Now we've got 4 times 5. Oops, I'll put my line in. 4 times 5 is 20, so that's 0, carry the 2. 4 times 3 is 12, plus 2 is 14, so 4, carry the 1. 4 times 7 is 28, plus 1 is 29, so 9. And again, we just move over the 2. Now here's the part that we have to be careful of. A lot of people look at this and say, well, this 0 is just going to be after the decimal point. Do I really have to add the zeros to get 0? And the answer is that at first, yes, you do. You have to keep track of those. 7, 5, and 0, of course, is 12, so 2 carry the 1. 1, 4, and 4 is 9. 1, 1, and 4 is 6. 5 and 9 is 14, so 4 carry the 1. And, of course, 1 and 2 is 3. Now we have to place our decimal point. We have 1, 2, 3, 4, 5 total decimal places in our problem. We start at the end of the number 1, 2, 3, 4, 5 decimal places in our result. We had to keep that 0 there at least until we place the decimal point, because it counts as one of those decimal places in our answer. Now at this point, once I've placed the decimal point, if I wanted to drop that 0, in many cases we could do that. In a few weeks when we talk about measurement, we'll talk about when that 0 is important, when it has meaning and we have to keep it, and when we can just let it go. Well, division with decimals. So let's do 17.918 divided by 3.4. Now, again, we showed you back on the second day of class the actual long method of doing long division, the original method with all of the steps in there. And, of course, it took a lot of space, and there were a lot of steps. Well, if we continued, if we kept doing it that way, long division with decimals is no different than long division with whole numbers. I look at place values. This is in the tens place. I would do 10 times the 3.4 is 34. That's too large, can't subtract that. Next place is the ones place. 1 times 3.4 is 3.4. I can subtract that. In fact, I can subtract it 5 times. So, do this. Times 5 gives me, well, 17, exactly. So I subtract, all that's left is the 0.918. So what I did there was I subtracted a set of 1, 3.4, and I did it 5 times. 1 times 5 gives us 5 up here. Next place value, I move to the tenths place. 0.1 times 3.4 is 0.34. I can subtract that from what's left. It looks like twice. Giving me 0.68. I subtract that, I've got 8. 3.238. Well, what I just subtracted there again, that was 0.1 of those 3.4s, and I did it twice. So that's 0.2. And I can continue on like this to finish up my division. So 0.01, the hundredths place, is my next place value. That'll be 0.034. I can take that out. Let's try it 7 times. 8, carry the 2, 2, 3, and there's nothing left over. So that was 0.01 times 7. or 0.07. So the result there is 5.27. Now, that's not how we've been taught to do long division anymore. We've been taught to skip all these steps over here. Well, when we skip all those steps, we lose track of the place values. So we have to compensate for losing track of those place values somehow. So what we've been taught to do is to take this problem here and change it before we do the division. And what we do is we take the number we're dividing by, which is the 3.4, and we get rid of the decimals. There's one decimal place here, so I move the decimal point over one spot to get rid of the decimal. That is now 34. And we were taught, however far you move it over here, we got to move it over here the same distance. So this becomes 179.18. Now the question is, why are we able to do that? Well, we've mentioned that fractions and division are kind of interchangeable. This is 17.918 over 3.4. And one of the things we saw with our fractions is I can multiply both the numerator and denominator by the same number, and it doesn't change the value of the fractions. If I want to move this over one spot, I multiply by 10. Well, I have to multiply the numerator by 10 as well. If I had to move it over two spots, I would have multiplied by 100 in both. So moving that decimal point over the same distance in both numbers is nothing more than using equivalent fractions. Now that I have eliminated the decimal point in the number I'm dividing by, I'm going to go ahead and start dividing. Just like our long division with whole numbers, we go 34 does not go into 1, so we'll leave it blank above the 1. Does not go into 17, so I leave it blank above the 17. 34 goes into 179. Let's go 5 times. 5 times 4 is 20, so 0 carry the 2. 5 times 3 is 15, plus 2 is 17. We subtract, there's 9 left. Now, before we bring down the next digit like we normally do, we see that we're crossing the decimal point. Before we can cross that decimal point, we have to slide it up into our answer. Now we can bring down that next digit, the 1. 34 goes into 91 twice. 2 times 34 is 68. We subtract 23. And of course, now we can bring down that 8. 34 goes into 238 7 times. And that's it. We're all done. 5.27. Now, moving that decimal point to get rid of it in the divisor definitely shortens up that process. Now, what I want to make sure we know how to do is let's divide. And I'll write it out. Well, we'll do it this way. 23.649 divided by 0.31 to the nearest thousandth. Well, first of all, let's write this out. This is going to be 23.649 under my division sign. 0.31 out here. Second step, we have to move that decimal point. Get rid of the one in the number we're dividing by. Remember, this is the one that matters. We don't care how many decimal places are here. That's the one that matters. So we have to move it over 2 places to get rid of it there. So that's going to be 31. We have to move it over 2 places here. So that becomes 2,364.9. Then we can start our division. 31 goes into 230. 31 does not go into 2, so we leave it blank above the 2. 31 does not go into 23, so we leave it blank above the 3. It goes into 236 7 times. 217. We subtract here. We get 19. Now we're okay to bring down the 4. We haven't hit the decimal point yet. 31 goes into 194 6 times. 6 times 1 is 6. 6 times 3 is 18. We subtract there. You have 8. Now, before we bring down the next digit, we do have to move that decimal point straight up before we cross the decimal point. Now we'll bring down the 9. 31 into 84 goes twice. 2 times 31 is 62. 27. Now, it looks like we're done because there's no digits left, but when we're after the decimal point, we can add more zeros and it does not affect the result. That 0 is after the decimal point. It does not change the place value of any of these other digits. So I can add it and it doesn't make a difference. So I'll add that 0 and bring it down. 31 into 270 goes 8 times. 248. We will subtract there to get 22. We can add another 0 and bring it down. Remember, we said we wanted to go to the nearest thousandth, so we got to keep going. 31 into 220 goes 7 times. So I'll put a 7 there. 7 times 31 is 217. And I subtract, there's 3 left over. Now we're at the thousands digit here, but that does not mean we can stop. We want to go to the nearest thousand. To the nearest thousandth means we're going to round to the thousandth place. In order to round accurately, we have to know what the next digit is. So we have to put in 1 more 0 and bring it down. Well, that makes this just a 30. Well, 31 does not go into 30. So that makes this next digit just a 1. So that's telling us to the nearest thousandth, this 7 in the thousandth digit would still stay a 7. So that's just 76.287. But we had to get that next digit, that 10 thousandths digit, so that we knew whether we stayed a 7 or if we had to round up to 8. Well, we can also run into problems like this. 42.7 divided by 0.53. When we go to do this, we have to move this decimal point 2 places to get rid of it in our divisor, the number we're dividing by. So that'll become a 53. Which means we have to move it 2 places over here as well. Well, we notice we run out of decimal places, so we do have to add a 0. This is 4,270. So you see the decimals are totally eliminated in our problem, but that does not mean they aren't still there. 53 does not go into 4, we'll leave it blank there. 53 does not go into 42, we'll leave it blank there. 53 does go into 427, 8 times. 8 times 3 is 24, so 4, carry the 2. 8 times 5 is 42, plus 2, or is 40, plus 2 is 42. We subtract, we've got 3. Bring down the next digit, which is the 0. Well, 53 does not go into 30. So we have to put a 0 there. We have to fill that place value above that digit that we just brought down. This 0 was the last digit we brought down. We have to fill its place value. Now, it looks like we're done, but we can actually keep going. We can add a decimal point here and add another 0 after it and bring it down. Now, before I bring that 0 down, technically, that decimal point that I added should be moved up into our answer. Now we've got 53 going into 300. 300 divided by 53, I believe, is 5. That would be 265 here. Subtracting gives us 35. We can continue to add a 0, bring it down. Let's say I want this to the nearest hundredth. So 53 goes into 350. Looks like 6 times. 6 times 3 is 18. Carry the 1. That's 31. That's going to be 32 left over. Now that's the 100th, but I said we have to go one place value past so that we know how to round. So we're going to add another 0. 53 into 320 actually does go 6 times. That would be 318. Still 2 left over. So now in this case, this 6 is telling us that this has to round up. Instead of 80.56, it's actually 80.57 that it's closer to. Any questions there? I didn't mention it yesterday, so I'll extend it out. Quiz 3, which is finishing up our fractions, is out there. I posted it, but I didn't mention it in class yesterday. So we'll give you until noon tomorrow, September 4th, even though it says September 3rd in Blackboard. If you've already done it, great, thanks. Homework for today. Is out of the little book. Units 12, 13, 14, and 15, the odds. So you guys have the last 12 minutes or so to get started on it if you want to. I realize logging in from home, I'm not going to force you to sit on the network and let me watch your work. So if you guys want to log out, you are welcome to. We'll see you all tomorrow.